Hello everyone, it's me Indramani Gemali, teacher for maths. Welcome you all in my today's session. As I mentioned in previous class, today we are starting new chapter. This is interesting chapter and very important for different branches of mathematics, which is algebra. So talking about algebra, this is the important part of mathematics, one of the branches of math that deals about different mathematical operations like addition, subtraction, multiplication and division. So at the same time, we can read on the slide. I have mentioned many things. What is algebra? What is its importance in our daily life? Where is algebra used? What are different mathematical operations? What are the different terms that we use in algebra? We can have a look on the slide now. Let's read out and get the idea about what is algebra. It talks about mathematical operations. There are different operations in math: addition, subtraction, multiplication and division, and with the help of this mathematical operations we solve mathematical problems. And there is connection of algebra in other parts of mathematics as well. So if we talk about what are the different terms that we use in algebra, there are various terms that we use. Like a term is variable. What is variable? What is the concept of this? What is the meaning of constant term? What are coefficient? What are polynomials and all? Basically, we will focus on today the different terms. Shortly I will talk on this, and then our main today's objective is what is factorization, what are factors, and we will practice some questions on factorization. So let's read what are variables, coefficient, constant and polynomials. So let me take an example here. Suppose 4x. This is a term, and here we can say 4 is the number part and x is a variable. Number part means simply the constant number. This is a number which can be positive, negative or any fractional number. X is variable. Why this is called variable? Its reason is simply x can have any value. X can represent any number, and 4 is coefficient of x. 4 is coefficient of x. This is constant. X is a variable. We say this is variable because it can represent any number like 1, 2, 3, 4, so on. And this is a term. This is an algebraic term because an algebraic term contains a number with variable or simply number or only variable. So let me talk about what is polynomial and what are the different polynomials that we need to learn. Talking about polynomial, there are different types. I am taking the example. Suppose 4x is first. 4x is square plus 2. 4x, there is a term, single term. So this is monomial expression. In polynomial, we learn about monomial, binomial, trinomial and polynomials. So 4x, if a algebraic term contains only one term, this is monomial. If there are two terms like 4x square plus 2, this is binomial expression. If there are three terms like x plus y plus z, there are three terms. Each terms are separated by plus sign. We also can put here negative sign. There are three terms, so this algebraic expression is trinomial. There are specific terms like monomial for one term, binomial for two terms, trinomial for three terms. If there are four or more than four terms, we simply say polynomials. Like if the term is 4x square plus y plus z plus 6. There are four terms and we simply say this is a polynomial. So the terms we use in algebra are: what is the concept of variable, what are coefficient, constant terms, polynomials. After this, let me talk about now where is algebra used. There is connection of algebra in our everyday life. We can say we can use this everywhere in our real life. Like if we bought some items from a shop, obviously there is use of addition, subtraction, multiplication or division, because we need to pay a certain amount of money to the shopkeeper after we bought any items. So there is use. Or you can see on the slide now, so I am displaying a slide. Here is one example. Let me read out this. You bought 9 items from a shopping mall and now we need plastic bags of any kind of bags to carry them at home. If each bag can hold only 3 items, how many plastic bags will require to put 9 items? It's very simple. We can see there are 3 different bags and different items are indicated by different numerical numbers 1, 2, 3, 4, 5, 6. These are different items which were bought. So here is the question. Total 9 items are bought and each bag can carry only 3 items. So how many bags are required to carry them? So it's simple. We can use a simple concept like x divided by y. So what is x? Number of items bought. And what is y? Capacity of one bag. Or without using this formula, we can easily identify how many bags are required to put different 9 items. So what I want to say here is, in our real life, there is use of algebra. This is one example. Second is, we can see other examples of algebra we use in our everyday life, like buying of vegetables, fruits, stationery items. There is use of addition or subtraction, any kind of mathematical operation. Similarly, we can read out other examples, we can find out other examples which are used in everyday life. Let's recall the concept of what is factor and what is factorization. This is the main topic I am discussing today after discussion of what is algebra, where is algebra used, and different terms of algebra. What is factor? Let me take in maths. If we take some examples, it will be easy to understand. So I'm taking one number, it's 12. And I'm explaining now what is factor and what is factorization. We can factorize 12. We can factorize this 12. Now what is factor? Factors are numbers or any algebraic expression that divides another number or algebraic expression without any remainder or exactly. So 1, if we divide 12 by 1, we can exactly divide without leaving a remainder. 2, 12 can be divided by 2. 2, 6 times is 12. 3, similarly 4, 6 and 12 itself. So these are the factors of 12. So what is factor? Factor is a number or any algebraic expression that divides another number exactly, means without any remainder. Here, if we divide 12 by 6, we can obtain 2, there is no remainder. If we divide 12 by 4, we can divide exactly 12 by 4 without any remainder. So these numbers are the factors of 12. Similarly, if I take an algebraic expression like x squared plus 2x, this is an algebraic expression, this is binomial expression. Here we can take x common, so what is left? X plus 2. X and x plus 2 are the factors of this expression x squared plus 2x. Its reason is, if we divide x squared plus 2x by x, there is no remainder. Or we also can divide this expression by x plus 2. And when we multiplied these two factors, we can obtain the original expression x squared plus 2x. So let me conclude what is factor and factorization. Factors are the expressions that divides another expression without remainder or exactly, and factorization is the process of breaking down. Factorization is the process of splitting a polynomial into its smaller part or into its smaller factors, which when multiplied together gives the original polynomial. Now we can take some of the examples. I have divided algebraic expression into different categories. Like first, let me talk about expression having a common factor in each of its term. Expression having a common factor in each of its term. That means 2a times x minus y plus, suppose let's write here 3b times x minus y. So I am taking an example. Here are two groups. If we consider this is first term and this one is second term in algebraic expression, x minus y is the common factor from first and second term. So we can factorize this expression by taking x minus y common. So if we take x minus y common, x minus y is the common factor from first and second term. If we consider this is first term and this one is second term, x minus y is common. Now what are the terms left? In the first term, 2a plus as it is 3b. So this is a simple example where this expression has a common factor in each of its term. So x minus y is common factor. Now if we try to multiply these two factors, if we multiply again these two factors, we will obviously get the original polynomial. So here factorization is process of splitting algebraic expression into the factors or into its smaller part, into smaller factors. Or we also can define factorization in another way. It is the process of expressing a polynomial as the product of two polynomials. So here this is the original polynomial, and when we factorize this, we obtain two factors x minus y and 2a plus 3. So this polynomial is splitted into two factors, and these two factors are in product form. When we multiply these two factors, we will obtain the original polynomial. Let me talk about next expression. Let me take example here. Ax plus by plus ay plus bx. We can say there are four different terms in the expression. This is a polynomial. There are 4 different terms. Now, after discussing about an expression having a common factor, now I am discussing how can we factorize this expression by grouping the different terms. In the beginning of the factorization, first of all, we try to find a common factor if there is any common number or letter throughout the expression. We try to find a common factor. So let's look at this. Is there any common factor? Is there any common number or letter? Ax plus by plus ay plus bx. One is always common. One is always common factor of any kind of expression. Any kind of expression. Here, except one, none of the numbers or alphabets are common. So in this case, this expression contains 4 different terms. So we factorize this expression by grouping. That means if we cannot factorize this by grouping these 2 terms and next 2 terms, if we try to take common from first and second term like ax plus by, nothing is common. So in this case, we will rearrange in a suitable group. We need to rearrange these 4 terms in suitable group such that every group has a common factor. So let's try to rearrange. If we rearrange first term with third, if we put first and third term together and second and fourth term, let's try what we will get. Ax plus ay. Here I am rewriting the expression by rearranging the terms. First and third term I am keeping it together plus second and fourth by plus bx. Let's see. This is a group, one group, and this is another group. So we are trying to factorize this expression by grouping the different terms of the expression. Now, can we take common? Let's say what is common. So a is common from first and second term in a first group. So a can be taken as common. X plus y are the remaining terms plus. So what is common here? B. Y plus x. So a times x plus y. So these are the 2 factors of ax plus ay. Similarly, b times y plus x are the 2 factors of by plus bx. Now, looking at the terms in the bracket, there are the terms x plus y and y plus x. It's same. X plus y and y plus x are same because there is positive sign. So again, we can take x plus y common, since x plus y is equal to y plus x. So there is no difference in x plus y and y plus x, because what is the sign of x? Positive. Y is also positive. Here sign of x and y both are positive. So if we take x plus y common, now what is the term left in first term? A, in the second term b. So this is how we factorize expression having 4 terms by grouping the terms in 2 different suitable groups. But each group must contain a common factor here. Here each group must contain the common factor x plus y and x plus y. So we could factorize this. This is one example I took here. How do we factorize the expression having common factors in the groups of term? Now let me take next example. Let me take next example. Next example, so I am taking here is p square minus 8p minus p plus 8. Let's try this. How do we factorize? Again, this expression contains 4 terms. In the beginning of the factorization, in the beginning, first of all we try to find if there is any common number from the entire expression. Let's see, p square minus 8p minus p plus 8, nothing is common. If there is nothing common, then we will try to rearrange in different groups such that each group has a common factor, or in some cases if there is chance of factorization without splitting into different groups. Let's try for that. If we cannot factorize simply by taking common from first two terms and next two terms, we need to rearrange. So let's try without rearranging what we will get. We can take common from first two terms and let's try from the next two terms. What is common from first and second term and then third and fourth? Here from p square minus 8p, p is common. So what are the factors of p square? We can express p square, p times p is p square. So 1p is taken as common, 1p is left. Now minus p is common, so what is left? 8 minus from minus p and plus 8. What is common? There is no number or letter common among minus p and plus 8. So obviously 1 is the common factor. So we can take 1 as common factor and p is left. After taking negative sign common here, plus sign now will be changed into minus 8. Why this sign becomes negative? Let's try this. Here this negative sign I have written same, minus sign as it is, but after taking a negative sign common out of the bracket, sign should be changed inside the bracket. Or we also can say this again by multiplying. If we multiply this minus 1 times p, if we multiply this, we will obtain the above expression. Minus 1 times p is minus p. So what is minus becomes plus 8. It's same. There should not be any change. Okay, so if we consider this is first term and this is the second term here, what is common? What is the common factor? P minus 8 is a common factor, so we can take p minus 8 common, and after taking a common factor we will write the remaining terms which are p minus 1. So this is the next example. Here are 4 terms, but we do not need to rearrange the terms because there is chance of splitting this entire expression into its 2 factors without rearranging them. So in fact there is no exact rule in factorization. To understand how to factorize this question, it depends on our practice. If we practice more and more questions, we will get the idea, we can get the idea how do we factorize this expression. For that we need to practice more examples, we need to practice more algebraic expression. So let's try now third example. Let's practice third example. This third example also contains now 4 terms. We can see in the slide I am writing question here. Example number 3, x square minus y minus x times. Okay, so let's write y minus 3 times x minus 3 times y. Let's try this question. How do we factorize this? Here are 1, this is second term, third term, but we need to open the bracket in the second term. Let's start this x is square minus, let's open the bracket, x times y is xy. So minus minus becomes plus, 3 times x, 3x minus 3y. Again, this expression contains 4 different terms. This is a polynomial, 4 different terms. Now, can we factorize this simply taking common from first 2 terms and next 2 terms or not? For this, we need to try this. If we try it to take common from first 2 terms and next 2 terms, we can factorize. If by taking common from first 2 terms and next 2 terms, we cannot factorize the expression, we need to rearrange. Like in first example, we need to rearrange the terms in suitable groups such that each group contain a common factor. What is common from x square and xy? So here x is common, x minus y, plus what is common from 3x and 3y? 3 is common, x minus y. Again, so x minus y is a common factor. X minus y is a common factor. So we can take x minus y common. So x minus y. So we have considered this is one term and this is another term. So here, after taking x minus y common, now what is left? X plus here 3. So these are the two factors of x square minus y minus 3 times of x minus 3y. This is the way how we factorize algebraic expressions having 4 terms. There are other ways, there are different questions. Let me take the next one. A square plus twice AB plus B square plus A plus B. It has got 5 terms. Here, this algebraic expression has got 5 terms. So let's try this. If we try to convert first 3 terms into a formula, like a square plus 2ab plus b square, we can convert this into a perfect square of a plus b whole square. Because what is the expanded form of a plus b whole square? A square plus 2ab plus b square. This is expanded form of a plus b whole square. Plus, let's write last 2 terms as it is, a plus b. Now, what we need to learn here is, what we need to know here is, what are the factors of a plus b whole square? Like what are the factors of x square, x times x? Because there are 2x. Similarly, what are the factors of a plus b whole square? There are 2a plus b. So a plus b times a plus b. These are the 2 factors. So let me factorize a plus b whole squared. Its factors are a plus b times a plus b plus what is common from a plus b? 1. So a plus b whole square. Its factors are a plus b times a plus b, but a square plus 2ab plus b square is an expanded form. Expanded form. There is difference between, in concept, expanded form and factors. Now what can we take common? A plus b, a plus b. 1 a plus b is common, a plus b. Now what is left in the first term? A plus b, and the second term plus 1. So this is the next example. So there are different types of factorizations we practice, and how to factorize a polynomial how to factorize algebraic expression, how can we factorize, it depends on our practice. Thank you all for being with me. This is all about for today's class, and have a wonderful day ahead. Thank you all.